What are node callbacks, promises, asyncs, and await? Today I am discussing parallelism versus concurrency, synchronous versus asynchronous, and how the JavaScript node event loop actually works. Might sound confusing, but it won't by the time I'm done. So for all of these things, the core concept that we're going to be going over is asynchronous. Not the keyword async, but asynchronous as a concept. Asynchronous comes from a Greek word, chronos, time, async, not in, which basically the difference is synchronous things are in time, asynchronous things are not in time. In code, all that really means is synchronous things run one after the other, asynchronous, not necessarily. So if you have console logs, console log 1, 2, 3, they just fire one after the other. That is a synchronous set of code, 1, 2, 3 in order. But sometimes in coding languages, you have things that take longer. So if you wanted to make a network request, you wanted to say get all your tweets, or you wanted to order something on delivery and you had to wait for it to get back, they take time. So you can't have console log 1, console log 2, 4 minutes, and then console log 3 because it blocks the whole thread. You can't do anything else. So asynchronous really is a way that we can do other instructions that might take a longer set of time, and it doesn't disrupt everything else that we're doing. It doesn't block the primary code thread. But this does kind of bring up the question, why does waiting for a network request block the code? Can we not wait for the network request whilst we do other instructions? And this brings us on to the concept of parallelism versus concurrency. JavaScript is a single-threaded language. A thread is basically a computer brain, so it's the thing in the computer that runs a task at any time. This basically means that JavaScript and Node can only really do one thing at once. In other languages like Java, you can have multiple threads, so multiple brains working on different problems at the same time, but you can have issues that like race conditions, blah, 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 and like syncing up memory can be difficult. So JavaScript is a little bit more opinionated with how it handles this, but that's kind of great for us because it removes a lot of the complexity with setting up some of the async sync code stuff. Concurrency means you can do multiple jobs, but you do them at different times. So bits of this, bits of that, and you put them together. Parallelism is when two things are running at the same time. If I was on WhatsApp speaking to two different people, that is concurrent because I'm typing to this person, then I'm typing to that person. I'm kind of doing them at the same time, but I'm not actually literally typing both at the same time. Parallelism would be like two Isaacs typing to two different people. Now, parallelism makes more sense because it would seem quicker because, two people are doing the work. However, there has an issue with syncing up the information because if Isaac 2 is trying to organize an event with someone on Thursday and then Isaac 1 is trying to organize an event with someone on Wednesday, it's difficult to cross over. I don't know what they're doing, they don't know what we're doing. Luckily though, we don't even have to deal with that because we're just working with concurrency and Node. That is a high-level overview of the concepts, but functionally it should be all that we need to get to the next step, which is the fun part, the keywords. Okay, so first we have a callback. Now, a callback is how JavaScript normally handles this whole concurrent issue and waiting for the code to execute. So if you can see the code here, we have a callback function at the very top, console start, refresh my timeline where we pass the callback in, and a console.log end. Now, a callback is basically when you send a function as an input, and the idea is that the function that takes however long to execute something will execute, and then when it's completed, it will call the callback. Bit confusing, but bear with me. Let's say we had a function which gets your timeline, so you wanted to get all your tweets from your timeline. Now, this could take 30 seconds to execute, and we don't want to wait that long. But the great thing is we wouldn't have to with the way this function works, because it would get your tweets, and then after it's done, it would call the callback and log them out. So the way this would look in your console if you ran it would be start, end, and then however long it took to get your tweets, then it would post out your tweets. So by using a callback, it's asynchronous because we're not waiting for the code to finish. We're executing the code as it goes, and then whenever the tweets come through, then we'll post them. That is how a callback works. Callbacks are kind of the core of what we're going over. They just kind of change their forms as we progress through the different steps. So promises kind of use callbacks, but they're a little bit more sophisticated. A promise looks like this. It's a type. So you have like return a new promise, and you have these two parameters that you pass in, which are resolve and reject. Now, the way this works is actually kind of cool. Promise has two callbacks. There is a resolve callback and a reject callback. If the request that you're trying to do is successful, you would call resolve, and if it fails, you will call reject. So two separate callbacks for if there's a failure and a success. Obviously, this does look like a little bit more work than what we had before, but what's cool is the way that we can now consume this in other functions. We get to use the then and catch. If you can see the code here, we have the refresh my timeline function, and we use then to get the resolve result. And if it errors, it calls the reject callback, we can catch it with the catch. So the nice thing about this is we can now see exactly how it works. We can see success and error. The way this function would run in the console is we'd see start, end, and then after the tweets are selected, we have our tweets. So in a way, this works exactly as the callback did before. I'm just showing you a different form in a promise. The reason promises are really cool is because they help you avoid callback hell. Now, callback hell is a little bit difficult to understand unless you've actually had to experience it firsthand, which is horrible, and I hope you don't, and you shouldn't, because we can now avoid it. If you wanted to chain requests on a promise would look, and then I'm going to show you how it looks with callbacks, and you'll see why we made this change. So on the second function here, you can see there are multiple .then. So you have refresh my timeline, there is a then, and then after that there is another then. Now, the cool thing about this is you can do this as many times as you want, and the catch is always going to be the same. If any of them reject, it will carry out this catch function. So this is nice. We can actually do steps. We have here, refresh my timeline. This then returns a process tweet, which is another promise. And then when that comes through, we get the process tweets and we console log them. So again, this would be console log start, console log end, and then console log process tweets. And this is callback hell. Can you see how busy and big that is? I didn't even want to write it myself, it's so nasty. I had to get this picture online. For every time you want to wait for something and carry out a new instruction, you have to make a new function and you have to put it in this big nested loop, and it's all nasty and hairy, and thankfully that's done with now. That was callbacks and the fundamentals of how they're used, and then promises were built on top to make it neater and easier to work with. And now we get to the final part, which is the async await, and I'm doing them together because they're fundamentally linked. You can't use one without the other. This is what I mostly use because I think it makes the code way more readable and easy to understand. At the stage of my career I'm at, that's actually one of the most important things. It's like, can people read it? Even myself, like if I come back to it 3 months later, do I know what it means? The .then, .catch, much easier to read than the callback stuff. However, is there a way we could make it even easier? The answer is yes. Now, this part might look a little bit confusing because it almost looks like it defeats the point of why we started this in the first place. So when I said there was synchronous code and you don't want to wait 2 minutes before executing the next function, this is actually kind of what async and await is. But truth be told, you want to use both approaches so that you don't block the main UI thread. Now, if you're on a web app and you click something and it says loading and you can't do anything else, that's a horrible experience. So we would use a callback in that situation. We'd use a callback because we need to wait for whatever request we're doing. However, in that function that's executing, await and async is a way to make this look a lot neater. So we're actually still dealing with promises in the same way, it just looks nicer. And the whole point of doing this is to avoid embedding, which is the whole callback hell stuff. If you can see the code here, refresh my timeline is actually the exact same function that we had before. It's a promise. So it returns that promise, resolve, reject thing. This code here, if we execute it would go start, end, and nothing would happen because result is just a promise. Like it would just console log empty because the result hasn't come back yet. It's going to take 30 seconds. But the code doesn't stop, it just executes. When using await with a promise, it basically awaits for the resolve value. So the successful value when it comes back, that's what it returns. And if we ran this function again using await, we would expect to see start, the tweets, and then end. Obviously, there would be a time difference. So it'd be start, wait 30 seconds, then tweets, then end. But fundamentally, it's the same thing. However, if you look at the code on the screen, you will see that it is highlighted underneath as incorrect with that red line. And that is because our function has not been described as asynchronous. So what we need to do is we need to put the async keyword at the beginning of the function, and now it works. And essentially async is just something for your functions which auto turns them into promises. So instead of it just being a function now that returns something, it's a promise that returns something. You see how that works? Okay, so cool. You've sort of made an asynchronous code synchronous inside it. The way you can really see the value of this is when you start chaining commands using the await keyword. And if you see the code that's on the screen now, you have get my results, refresh my timeline, process tweets, and they're one after the other. And to me, this is so much easier to read. By using await, they're still promises, but we can just await for the result instead of having to do the whole .then thing. It's really nice as well because you define the variables as they come in. If it's not working, you don't know why it's not working. You can at the end like console log all the variables so you can see what was output where. Makes it a lot easier to track, and personally I think a lot easier to see. So that is the difference between concurrency and parallelism fundamentally, and how JavaScript uses callbacks to do asynchronous code. I've got some cool resources in the description which go over the event loop, which are far more detailed. I kind of gave an overview so that people can understand functionally how to use it in program. But if you want to know how the node event loop works, it's actually well worth looking into. If you know someone studying JavaScript and they're trying to get better understanding what they do, or they just don't know what this stuff is and need to get to the next level, send them this video so they can make a more informed decision. Thanks guys.